Hello, students. We are going to learn today about quadratic applications, and a couple of things that we are looking at right now is that this parabola has been displaced. As you can see, it's not in the y-axis, a little bit displaced. A couple of things that we notice is that we have this part missing, but it's missing in purpose because it's not really relevant to the problem that we're looking at right now. It's stretched. We see that it's counting by fives, so we see that it's stretched. So there were a couple of modifications, but this graph is going to help us answer a couple of questions, and these are real life applications. So the graph below represent the path of a golf ball after being made from a tree of a tee. So basically, the ball starts here, so it didn't start all the way on the ground. So this is time zero. The ball climbs and then basically lands here, and this is the end of the flight path of the ball. So let's answer a couple of questions here. This graph is an example of what type of function? So it's a quadratic. Simple. Quadratic. Okay. This graph represents a golf tee shot that is made from, okay, so how high was the ball when the shot was done? So right here, here's my answer. So it was at 20 meters high. Okay. The ball flight lasted about, so how long was that flight? So the ball was flying, and then when it hit the ground, here is when the flight ended. So that time, I would say that it's about, I don't know, let's say 8.5 seconds until the ball landed on the green below the tee. Blank in second is represented on the, okay, so here, let's say in seconds. So we are talking about the axis. So here, time in seconds. Okay, so let's write here time in seconds is represented on the x-axis, while height, meters, okay, in meters is represented on the y-axis. Okay, about 48 meters is the blank height reached by the golf ball. So let's see, 48 meters. Where is that? 48 meters happens to be somewhere here. Okay, and apparently that happens to be my maximum. Okay, okay, so we'll say maximum. How many seconds elapsed when the ball was 48 meters or more above the ground? So here we need to pay attention on how much time was the ball above 48 meters. So if we take a closer look at what is going on here, the question is, from how much time was the ball up here above 48 meters? So that happens in between this time and that other time. Okay, so all we need to do is a quick subtraction here of 5 minus 2.5, which happens to be almost over here. And we will say that the ball was about 2.5 seconds above 48 meters. Okay, so 2.5 seconds. Okay, the blank is the highest or lowest point on the graph of a parabola. Okay, so here is a little bit of vocabulary that you have learned, and we're gonna put here the vertex. That is the highest. Okay, the vertex is the highest or lowest point of the graph of a parabola. The point that represents where the ball hits the ground is known as the, so here the question is, what is this point here? Okay, when it hits the ground. And that point, we have a couple of names. So we can call it x-intercept. We can call it the zeros. We can call it the solutions. Okay, and we can call it the roots. And that is that point. So let's see, the point that represent where the ball hits the ground is known as the, let's call it x-intercept or 0. The coordinate 8.50 represents the, okay, so 8.50, this is x and that is y. So that is talking about precisely where it touches the ground, okay? The coordinate 8.5 and 0 represents the moment. That's right here, moment. When the ball hits the ground. Okay. Basically, that is all to that graph. Let's see the next sample. A bakery determines the following relationship between the price of its cake and its daily profit. The following graph show this relationship. Okay, so what do we see here? We see that as the selling price increases, so is the profit until a moment, until here. So when we start increasing the selling price from this point forward, the profit starts to decrease. That's what we see here. Okay, this is the relationship that we have. So if we were to maximize, we would use this type of graphs and equations to maximize our profits. So let's see, what is the range? So okay, so to answer this, what is the range? We need to understand from where to where we have information. So our information, the y-axis, this is the lowest point, and my highest point happens to be over here. Okay, so I will say the top one is 275, and the lowest one, I would say about, I don't know, let's say 170. Okay. So what is my range? Well, my range goes from as low as 170, greater than or equal, less than or equal to 275. Okay. What does it mean? Well, it means that selling cakes from between $2 up to $9 will give us a profit in between 170 to 275. Okay, the profit could be any number, any amount between $170 to $275. Okay. So what is the maximum profit? Okay, so the maximum profit, as I was talking, is right here. This is my maximum profit, and it happens to be at my vertex right here. Okay. So the maximum profit will be $275. Okay. If we sell the cakes for about $5.50. Okay. Right, 75. I should write here 75. 275. Basically, that's all for this video. Now, answer the assignment and just practice. Good luck.